Okay, so I went around and I'm pretty sure I saw everybody got the 89 cents for the price per topping. But what did you guys do to get that? Subtracted the prices. So you found the difference in the prices. And then what? Why two? That's the difference in the toppings. And so very good. So that was 89 cents. All right. And then how much if you just get ice cream with no toppings? So that's taking one topping price and subtracting how much one topping costs. Very good. All right. No. That first one is two toppings, right? Strawberry ice cream. Strawberry ice. Okay, it's okay. You're fine. All right, and then we have the graph. All you really need to draw a line is 2 points. So you could. I saw a lot of you getting like really beautiful lines where you just kept going up the slope. But all you really need to do is do one topping for 479, and then three toppings for 657. You could do 0 and then 3.9 if you wanted to, but anyway, that gets you a good line. But you were also on step 2 supposed to write the equation. And so what you probably did is do the base price plus the price per topping times the number of toppings. All right, so you can put as many toppings as you want to as long as you're willing to pay for them. Okay, and then number 3, we have the other size, the gotta have it size. And the toppings cost the same for all sizes. And so we know 4 toppings was 806. And then so I saw a lot of you just using logic and your brain and knowing that 5 toppings that you would add 1 of the 0.89s. And then for 7, you would add 3 of them.
You add 3?
You add 3 89 senses. You add 3 slopes basically. Because 7 is 3 more toppings than 4. Okay, gotcha. All right, and then the last question, I'm not sure if you guys figured out, is kind of worded in a way that was a little bit confusing, but they wanted you to not know how much the base cost of a gotta have it and just use that $8.06 and then figure out a formula you could use. So you're going to add slopes to it. So how do you figure out how many slopes to add to it? Close. It's going to be x minus, but it's not going to be 1. What's it going to be? 4. Because that's what I did, like kind of in my head to figure out this 1 and this 3 is I took however many toppings it was and subtracted 4. Good job, guys. All right, so let's go on the back to the official notes. Fill these in. All right, so this lesson. Okay, so let's talk about linear relationships. So all linear relationships have a constant rate of change. Now, in my AP pre-calculus, we've been talking about rate of change like since the first day of school. But I tell them like almost every day, the rate of change and slope, we're talking about the same thing. So there's a constant slope or a constant rate of change on linear relationships. So to find that rate of change or to find the slope, what do you do? Yeah. So it's an old formula you guys learned back in Algebra 1, where you subtract the y's on the numerator and subtract the x's in the denominator. Now the order kind of matters. You can do y1 minus y2, but on the denominator you have to make sure you do x1 minus x2. So you have to keep it consistent. Now there's other ways we can figure out the slope. What I like to do is a little different. Like you basically doing the same thing, but I figure out the change in y over the change in x. So anytime you see that Greek letter delta, it looks like a triangle, it means change. So you can just like, if your y changed from 7 to 15, how much did it change? Or, yeah. Or your x changed from, see if you know this one, your x changed from -2 to 5, how much did it change? So, yeah. So sometimes it's easier to do it in your head than to actually use the formula, but it's up to you. Either one will work. All right, now this is a formula that we're gonna use in here that you might not have used in Algebra 1, and it's called point slope. Point slope form. Now I think in Coffee County that in Algebra 1 they don't use this form. They use another formula to do all the things. I personally like this form better, but I don't teach Algebra 1, so it's different. So point slope form, basically what we can do is take this slope formula and get this out of the denominator. So what would you do to that x minus x to get it out of the denominator? Multiply by it. Good. So point slope form is going to be y minus y1 equals m times x minus x1. And you use that form when you have a point and you have a slope and you want to find the line. That's why it's called what it's called, point slope. So m in this case is the slope, and x1, y1 is any point on the line. So you can get more than one right answer whenever you're doing point slope form, and it's fine. All right. And then the last form, I know you know, or you have learned it. So when you guys hear slope, what's the first thing that pops in your mind? Yes. Yes. M is still the slope. What's B? Yeah. Now on these conceptual problems that we do a lot, like especially like the one we just did, B was the base price. And it's kind of convenient when it's in slope intercept form that B ends up being the base price because it starts with a B. That can help you remember it that way. All right, so let's look at a conceptual problem about renting a U-Haul. So the cost of renting a U-Haul in Chicago is given by that formula, where M represents the number of miles driven. So in this formula, what does that 19.95 represent as far as renting this U-Haul? Base price. It's the y-intercept. I don't want you to say that though. I want you to talk about renting the U-Haul. So it's the base price. So it's what you would pay if you drove 0 miles. So when no miles are driven. Okay, so if we're thinking about renting this U-Haul, what do you think the 1.49 represents?
Per mile after buying the U-Haul.
Very good. It's the additional cost per mile. All right, you guys are good. Professional interpreters. All right, so number 2 doesn't have any context. It's just a regular old line graphed on the coordinate plane. And we want to write the equation for this line. So to write the equation, we do need to know the slope. So you can find the slope 2 different ways, and it's completely up to you. You can take the points and actually do the subtraction on the top and the bottom, or you can count. Just figure out the change. I'll do it both ways. You can decide which way you like better. But if you're going to use the formula, you would take a y and subtract another y from it. So it would be -5 minus 2 in the numerator. And then the denominator, you're going to keep the order the same. It's going to be the x minus the other x. Now, we don't like minus and negative, right? I would change that to plus and positive. You could do this in your head, or you could type it in the calculator. So it's like you owe $5 and you borrow $2 more, you owe 7. And then we're just adding in the denominator. So you can use the formula. If you're a formula person, you probably like it that way better. Or you could just count. So to get from this top point to the bottom point, you're going to go down 7 and you're going to go right 16. So that's your slope. Down 7, right 16. So it's completely up to you how you want to do that. All right. And then to get point slope, we can use either point. So do you guys have a preference, the top point or the bottom point? Anybody have a preference? No opinions? Okay, let's use the top point. So that's going to be our x1 and y1. All right, I'm going to rewrite down point slope form. You don't have to because you can probably see it on your page, but I kind of like to see stuff when I talk about it, and it's off my page right now. Okay, so that's it. That's the form. So I'm just going to take 2, and I'm going to put it in for y1. I'm going to take the slope I just found and put it in for m. And then -7 and put it in for x. But I'm not going to do minus -7. I'm going to do plus positive 7. And that's it. And I'm fine with you leaving it like that. There are other forms we could write this in. We could solve it for y. It's just, I don't think it's important. Just being able to give an expression for the equation is fine with me. And then there's another one that is also 100% right. There's a bunch of them that are 100% right, actually. All right, any questions? Okay, we have a couple more. They're both conceptual problems. So 3 is about a wedding. So a wedding venue charges a flat fee of $900 and an additional $35 per guest attending. Let's just start with that. Let's write an equation that models this situation. Yes, sir? Yes. The base price plus not 35 cents. That'd be great, actually. $35 per guest. And you might put a little note that to let X equal number of guests. All right, so let's say a couple has a budget of $500 they can spend on this venue. How many guests can they invite? So would you put 500 in for X or Y? 5,000. Would you put 5,000 in for X or Y? Y. It'd be pretty bad if it was 500. They couldn't even pay the base price. Yeah.
500 is like, what is it?
It's 5,000. It's not 500. I said the wrong thing. That's a Y. That's how much they can spend.
Oh, that's the budget?
That's their budget, $5,000. I just kept saying the wrong thing. We're looking for how many guests? Y'all working ahead? Nice. All right, this gives you a linear equation that's fairly easy to solve just by subtracting 900 and dividing by 35. Now, you never want to have a partial person. So if they don't want to go over budget, then they would need to have 117 guests. This is good to know because y'all probably have a wedding one day. Don't want to go over budget. All right, and then the last question is about Netflix. So in 2013, Netflix reported sales of 4.37 billion US dollars. And then in 2016, their sales were $8.8 billion. Let's assume that the growth is linear. We're going to do a couple of estimates. So for 2015 and for 2020. Now, I probably should have changed this problem a little bit because 2020 has already happened, but let's pretend we're figuring this out in 2016. All right, so if I want to go backwards to figure out the estimated sales in 2015, what could I do? Oh, I need to do something first I haven't done yet. What do I need to figure out first?
I know how many, like the growth a year.
The slope. Figure out the growth a year. That's going to be the slope. Very good. So we'll subtract the change in sales. And then over the change in years. How many years have changed?
2016, 2013.
Yeah. 3 years. Whoa. So it looks like their growth is $1.487 billion a year. All right. So then if I want to figure out their sales in 2015, estimate it, what would I do? I don't have to write an equation. I can just use the information here. Either one. I think it might be easier if we start with 2016. So if I take the 2016 minus, because that's 1 year away, that's going to be $7.34 billion. We're going from 16, 4 years, so 4 slopes. I think Netflix is doing pretty good at this time, if that's right. Now, the last question is, which estimate do you think is likely to be more accurate? The one that falls in between your two data values or the one that's on the outside of your data values? What do you think? In between is more accurate. That's called interpolation, and then the other one is extrapolation. If you take statistics at some point, you'll learn a lot of stuff about that, but it's going to be more accurate in between the two data points. So I'm almost out of room. You might be able to fit it better than me. I don't know. But I want you to write that 215 is more likely to be accurate. Because it falls between the data. Because like since 2016, there's a lot more streaming services, so their sales probably didn't continue on that linear growth.